Here we are at our example 5 from our 8.47 notes. We're asked to multiply the rational expressions. Now, when we see that, what might first come to mind is actually going ahead and distributing items to all the different terms. And unfortunately, though, that's actually not the route we want to take, because we can actually make our lives a little easier and see if things cancel out right away, making then our final rational function or expression much more simplified, pretty much. So what we're going to go ahead and do is actually factor what can be factored. So for example, this top left item, we can go ahead and pull out a negative x. They both share that. So we have negative x times x minus 6. Actually, if we pulled that negative x, that would take out that negative as well, so we'd end up with positive 6. On the bottom, we cannot actually factor this out at all, so he's still just x plus 5. For this top right item, we have x squared plus 3x minus 10. We can go ahead and break that down to be x plus 5 times x minus 2. And on the bottom, we can break this down into x plus 6 times x minus 2. And again, we are still multiplying these two items together. I'm going to go ahead and change this x, this time symbol, with a period so that we don't mix it up with an x value. Next, what we want to go ahead and do is cancel out what we can go ahead and cancel. So this guy has an x plus 6 on top. This one has one on the bottom. And because we are multiplying, key point there, because we are multiplying, we can go ahead and cancel these out. If we were doing maybe another operation, we wouldn't necessarily be able to get away with this move that we're seeing right now. The x plus 5, there's one on top, one on bottom. We are multiplying these two, so we can go ahead and get away with that. The x minus 2's also drop out, and so it looks like the only thing left over is this negative x. Kind of a parallel with why this actually works when we're multiplying is if we go back to properties with fractions. Let's say we have a fraction, let's go with 3/8. And then we have another fraction that we are multiplying this by. We'll say 4/7. What we can go ahead and do is break down this 8. So on top we would still have 3/8. I'm sorry, 3 instead of 8. We'd have 2 times 4, because that still gives us 8, times 4/7. Well, we can go ahead and cancel these 4's out, and then leave us with 3 on top still, over 14. So that's one route that we could take. Another completely different route, if we tried it, would be actually just multiplying these two tops together. So 3 times 4, we end up with 12. On the bottom, we have 8 times 7, which is 56. Now we can go ahead and divide both the top and the bottom by 4. They're both evenly divisible by 4. When we divide the top by 4, we just end up with 3. And when we divide the bottom by 4, we would end up with 14. Now, we want to avoid taking this route when we're talking about rational expressions. And the reason for that is you will end up with things that have incredibly high degrees sometimes. So for example, if we did this one, we would end up with, let's actually do the actual multiplying out. We'd end up with negative x to the 4th, if you distributed this, minus 3x cubed plus 10x squared. And then we're going to do our negative 6x. So negative 6x times x squared would be negative 6x cubed. Negative 6x times that 3x gets us negative 18x squared. Negative 6x times our last item, negative 10, gives us positive 60x. was, yeah, probably. Actually, no, I apologize, that was negative. But the idea here is when you start, maybe you could combine some like terms. So again, this is just the top. We're not going to really get too much into the bottom, but it's kind of the same principle. And we have, what, negative 28, no, negative 8 x squared plus 60x. And you could go ahead and pull out, for example, an x. Okay, you can pull an x out. You'd be left then with negative x cubed minus 9x squared minus 8x plus 60. And believe it or not, in some way, this can go ahead and be broken down. This can actually be factored. And the reason I know that is if we have this big crazy polynomial, it would actually be broken down into some form of this. Okay, so that's why we instead go ahead, like, you're multiplying all those items, so you would end up with this. But then imagine trying to break that down. It can be done, but it's really, really tough to do that. And the same thing would happen on the bottom if you tried just distributing all these items. You could eventually just break it down, but make your life a little easier. Just start breaking things down immediately when you see two rational functions being multiplied together. So again, we want to just avoid this entire setup. If you can factor stuff out, go ahead and do that. Again, though, that is example 5 from our 8.4 set of notes.